Assalamualaikum warahmatullahi wabarakatuh. So today our group will present PPT presentation by an enterprise network by group SEN. SEN stands for Shakir, Afiq and Naim. Our group member, the first one is Fakhr Naim, the leader of the group, Afiq Fariza, and me, Shakir Zufairi. Scenario 1. Expanding business to remote location. Company, Mari Gadget 3 new offices, rural limited infra, suburban business park, city center. For each location, I recommend 3 different internet-based one connectivity option with justification. Cost, ballparks, reliability, security and availability consideration plus potential challenges. A rural location, limited infrastructure. Option 1. 4G or 5G, cellular, broadband, LTE or 5G SIM router. The first one, description and justification. Ideal where wired lines unavailable, supports VPN and remote apps. The second one, bandwidth, 10 until 300 Mbps, depends on signal and provider. The third one, cost setup USD 150 until 500, router monthly USD 30 until 150. Number 4, reliability and uptime. Moderate, depends on coverage, use dual SIM for redundancy. Number 5, security, supports IPsec, VPN and encrypt data traffic. Number 6, availability, widely available if mobile coverage exists. 7, challenges, variable latency, increased data caps, contention during peak hours. A rural location, limited infrastructure. Option 2, fixed wireless access, FWA, wireless ISP, WISP. Description and justification. WISP deliver higher throughput than cellular in some rural areas via a local tower. Good mid-term option if available. Number 2, bandwidth, 20 until 200 Mbps, typical line of sight often required. Number 3, cost, moderate setup antenna and CPE USD 200 until 800. Monthly USD 50 until 300. Scalability, upgrading by plan or adding more radius. Reliability or SLA. Many WISP offer business SLA performance sensitive to weather line of sight. Redundancy, VIA, secondary cellular link recommended. Security, supports VPN, may offer managed firewall, encrypt traffic, IPsec or SSL. Availability depends on regional WISP presence. Number 7, challenges, requires lines of sight, equipment, alignment, seasonal weather impacts. Option 3, satellite internet, LEO or GEO. First one, description and justification. Last resort when terrestrial and cellular are inadequate. Modern LEO providers offer much improved latency bandwidth versus old GEO. Bandwidth, GEO low Mbps to 50 Mbps, LEO 50 until 300 plus Mbps varies. Latency, GEO high 600, LEO moderate 30 until 80. Number 3, cost, high setup, dish modern USD 400 until 2000, monthly USD 50 until 500 depending on provider and plan. Scalability, limited by plan tier. Number 4, reliability or SLA varies. LEO generally good, but weather and antenna alignment matters. Some providers offer business SLA. Security works with standard site-to-site, VPN, encryption mandatory for sensitive data. Availability global LEO better than WASP cellular in very remote spots. Challenges data cost, possible fair use limits, higher latency for old GEO system. Subrohan Business Park. Option 1 business DSL, VDSL or cable. Description and justification. Often readily available with stable rates, low cost for moderate bandwidth. Bandwidth DSL, VDSL 10 until 100 Mbps, cable DOCSIS 100 until 1000 Mbps depending on plan. Cost, low setup modem or router, monthly USD 30 until 200, scalability, upgrade plan or move to fiber. Number 4, reliability or SLA, consumer plans, limited SLA. Business class plans available with SLA, redundancy, VIA, second ISP advisable. Number 5, security, standard VPN, IPsec. Supplement with firewall or IDS. Number 6, availability, high in suburban parks. Number 7, challenges, shared medium cable, can see contention, DSL distance limitation. Option 2, fiber, FTTX, business Ethernet. Number 1, description and justification. Best performance and symmetric bandwidth. Ideal for cloud apps, backups, video conferencing. Bandwidth 50 Mbps until 10 Gbps, symmetric option. Number 3, cost, higher setup, installation fees and monthly USD 200 until 2000 depending on speed, scaling by ordering higher capacity. Number 4, reliability, SLA, high carrier, SLA with guarantee uptime, better latency, option for active standby dual provider. Number 5, security supports private VLAN, MACsec in some providers pair with firewall VPN. Number 6, availability high in many suburban business parks but requires provider fiber reach. Number 7, challenges, lead time for installation, higher cost. Subrohan Business Park. Option 3, SD1 over broadband multi-ISP. Number 1, description and justification. Aggregates multiple low-cost broadband links, enable intelligence parting and QoS. Good balance of cost and resiliency. Number 2, bandwidth, sum of link to 100 Mbps. Cable links can be combined logically. Number 3, cost, SD1 appliance subscription, one time USD 500 until 2000, monthly USD 50 until 300. Broadband cost as above. Number 4, reliability or SLA with multiple ISP links, high availability and path failover. SLA depends on ISP chosen. Number 5, security. SD1 often includes built-in encryption, centralized or policy and segmentation. Number 6, availability, readily available. Challenges, requires appliance and management, some learning curve. City center, bus link. Option 1, dedicate fiber, metro internet. Description and justification. Highest performance, low latency, recommended for heavy transactional workloads and conferencing. Number 2, bandwidth 100 Mbps until 10 Gbps plus symmetric. Number 3, cost, setup moderate high, monthly USD 300 until 2000 plus scalability via ordered speed. Number 4, reliability, SLA, excellent SLAs, carrier redundancy option. Number 5, security, strong supports private connectivity, VLANs, MACsec and direct connections to cloud provider. Direct connect or express route. Number 6, availability, very good in city centers. Number 7, costs are sometimes contract or term commitments. Next, I will give Afiq will continue.
Option 2, Subrohan Business Park. SD1 with multi-carrier backhaul MPLS replacement. Number 1, description and justification. Combine public internet and multi-ISP link but with centralized control, but steering, application awareness, good for hybrid cloud. Number 2, bandwidth, Ethernet, depend on link choose, cost, application, app line and subscription, USD 100 to 500 per site plus ISP fee. Reliability, SLA, high when used with multi-carrier and SLA contract. Many vendors offer managed service. Security, end-to-end encryption, segmentation, zero trust features. Availability high, challenge vendor selection and operating overhead. For option 3, carrier MPLS manager VPN. Description and justification. Traditional choice for repeatable behavior and strong SLA across multi-site. Useful if site-to-site, strict QoS and creating part equipment. Bandwidth, typical 2 Mbps, 1 GB, depending on contract. Cost, higher monthly rate and possibility medium contract term. Installation fee. Reliability, SLA very good. Carrier SLA often high price. Security, private one. Logical separation plus option encryption. Availability, widely available in micropolitan areas. Challenge, cost and less flexibility scaling than internet-based SD-WAN. Scenario 2, optimize one performance, troubleshoot and fix. A, likely root cause, bandwidth screen, unlinked saturation, unsubscribe link, higher latest or jitter, pure route, long pass satellite link, packet loss, intermediate hardware, noise link, ISP issue. Improve QoS, no privation, real-time traffic, compete with bulk transfer. Routing problem, suboptimal pulse, static route, ensure routing. Security overhead, CPU bomb, encryption on router, causing to bomb pass. 7. Application level issue, misconfigured client, shitty apps. One device, CPU or memory limit. Older router, UTMS, underpowered. B. The logistic test, run now. Check back connectivity, latest pin to HQ. Trace route to detect path challenge. Make sure bandwidth and loss. Check jitter and packet loss. Monitor interface analyzation and error, route and switch so interface. Look how drop error. Inspect VPN route, CPU, route CPU load during peak. Check for encrypto engine overload. Application performance trace, packet capture, Wireshark during slowness. Check event log on firewall, SD-WAN, controller for tunnel, flag or rekey. C. Recommendation and optimization technique, bandwidth connection, QoS or traffic shaping principle, provide real-time flow and business critical apps traffic, deploy disk, bulk transfer, backup large file scenes, action. Identify critical traffic by IP, port or application. Configure class-based QoS, mark DSCP, EF for voice, AF for WAN for important video, BE for batch effort, policer for non-critical flow, shape outbound or outbound to private buffer flow. To latency and TCP efficiency. 1. Optimization technique, compressing query TCP, acceleration control optimization. HTTP object caching, SMP optimization, duplication, product 1 optimization, reversible peak streaky SD1 or SD1 application which optimization features action deploy 1 optimization or able in SD1 optimization between HU and branch for KT control 1 acceleration route to issue dynamic route or and path selection. Use dynamic route BGP or OSPF between site and multiply unlink where optimization BGP for multi-carrier path control and traffic engineering. SD1 use application awareness path selection monitoring RTT jitter loss and strict traffic. Accordingly, use link A for low latency, flow link B for bulk. Action: implement BGP with approaching low for and communication for all configure SD1 policy. Security overhead, optimization equation. Problem: IP second encryption can be CPU heavy if device like crypto or offload. Solution: encrypt router, aware firewall, support hardware crypto acceleration, offload. Use modern cheaper suite that are secure and efficient. Give authorized encryption with a good performance on supported hardware. Configure short SA lifetime only if necessary to figure require cost decryption. Action: move heavier encryption to deprecated crypto applicate or it that was hardware crypto overhead. Packet loss and link head. If packet loss 1% contact ISP, consider redundant link. Use FEC, forward error code. Device resource limit. Update hardware, route and firewall. If CPU or memory is quicker, monitor CPU during peak and check per load counter. D. Example recommendation plan. Step by step. Run IPERF3 at peak time to qualitative throughput and MTR to identify low and latency. If unlinked started, increase bandwidth or add secondary bonded link. Implement SD1 to aggregate. Implement QoS making and policy at branch edge. Provide confession and critical export. If encryption CPU is high, able hardware crypto to upgrade device switch to AES/GCM. Deploy 1 Optimus or Sandwich as you want. Encryption features for TCP heavy apps. Use BGP/SD1 policy for path steering. Configure head. Provide RTT jitter loss to choose best byte. 7. Monitor net flow as float and set alert. Iterate. Scenario 3. Security breach investigation. Hardware taps vs software signature. Both hardware tap and software signature are valuable apps. Hardware taps provide reliable, tamper-resistant, full duplicate visibility with minimal performance impact and are therefore forensic capture in high throughput network. Software signature Wireshark are flexibility features rich analyze tools that are easy to deploy but many miss traffic, can impact host performance and raise legal privacy and consideration. A. Hardware network tab. Advanced. Complete visibility. Copy raw traffic. Both direction. Include pre-mirror packet. Zero performance. Impact or production device. Passive tab don't introduce latency or packet loss. Disadvantage, cost and specificality deployment, more efficient, frequently on-site physical installation and cabling change, less flexibility, harder to responsivity quickly compared to software, single point of feature reach if not passive, active inline tab to introduce risks, use passive where required. Best use case, long-term forensic capture high speed link, complex environments where temper, advanced and full fidelity are required.
C. Legal and ethical consideration. Privacy law capturing network traffic may include personal data, follow local laws, PDPA Malaysia, see GDPR if EU data evolve, obtain legal guidance if personal data or cross-border data are evolved. Company policy and consent. Ensure monitoring is authorized by company policy and employees are informed per law regulation. Chain of custody for evidence if prosecution or forensics likely use temper evidence, hardware capture, document procedures, timestamp and receive logs. Minimize data collection, capture only what's necessary, redact when possible. D. Recommendation for Mari Gadget. Immediate response, use software, sniffers, Wireshark, TCP dump on mirror port to quickly identify suspicious flash protocol and endpoint. If ongoing or higher speed capture required or compliance needs, install a hardware tab with a dedicated forensic capture appliance, packet broker plus storage plus IDS or IPS integration. Hybrid approach, best practice, use hardware tabs on core link feeding a capture appliance, use software sniffers for targeting, rapid analysis, maintain legal approval and login. Next is scenario 4, wireless network performance analysis, router Wi-Fi analyzer vs commercial software. A. Router build Wi-Fi analyzer. What it typically offers. Features: basic client list, signal strength, RSSI, per client connect can channel, basic channel utilization, some interference detection, number of client, and throughput graph. Some enterprise AP show airtime usage and client SNR. Pros: immediate vendor integrate, no additional cost, shows AP side view and per SSID stats. Cons: limit RF detail, no spectrum analysis, may not show non-Wi-Fi interface, interference, window UI or matrix may be basic. B. Commercial software-based Wi-Fi analyzer, Ekahau, a magnet, net spot, and acrylic. Features: detail, head map, spectrum analysis with external sensor, channel overlap visualization, packet capture, advanced matrix SNR, battery rates, guide troubleshooting, reporting, planning, and predictive modeling. Pros: rich diagnostics planning tools, visualize interference, correlation with client issues, enterprise grade reports. Cons: costly enterprise license, some require external spectral analyzers or specialized adapter for full capability, stable learning curve. C. Wireless spectrum analyzers. What they do: detect non-Wi-Fi interferences, source, microwave, cordless phone, Bluetooth legacy devices and radar, show RF energy across frequencies, essential when interference suspect. Router analyzer usually cannot detect non-Wi-Fi interference. Commercial tools plus USB spectrum, dongle or dedicated hardware needed for full spectrum. D. Network monitoring tool. Example, PRTG, Zobix, SolarWinds. Track battery, device head, client, cloud count, Signatrend, AP, CPU or memory, and generate alerts good for long-term trend analysis. E. Dionysus step practical. Collect AP and client metric for router or AP controller, RSSI, SNR, battery count, client count, fiber AP channel usage. Scan for channel overlap. Use analyzer to see which channel are congested. 4 2.4 GHz try channel 1/6/11 for 5 GHz big list congested. Perform spectrum analysis if interference suspect RF spikes non-Wi-Fi devices. Check hardware placement, AP head, obstruction, reflective surface, client density. Measure throughput and latency at client using hyperfeaturing and check rotary or transmit rates. Identify overload APS, client roaming issues or many low throughput, client causing a time congestion. Analyze authentication event, radius timeouts, and DHCP issues causing disconnection. F. Solution and recommendation. Channel planning, move congestion AP to non-overlapping channel. Use 5 GHz as primary and for capacity. Consider 6 GHz, Wi-Fi 6E if support and devices available. Reduce core channel interference. Use proper transmit power. Avoid too high power that cause client imbalance. Balance aptX power and client density. Enable band steering. Push capable client to 5 GHz. Use airtime, fairness or QoS. Prioritize voice or video and limit slow client. Upgrade to modern APS Wi-Fi 6 or 6E AP Gen. Handle higher client densities and OFDMA or target wait time, improve performance. Add AP or reposition for dead zone or heavy user density. Add AP with proper channel planning. Use wired backhaul or fast mesh. Ensure AP uplink have sufficient bandwidth. Avoid multiple wireless backhaul hoops. Use commercial analyzer for chronic issue. If interferences or designing problems suspect, run aside the server with a commercial tools, heat map and spectrum to produce a remediation plan. With monitoring and baseline, deploy network monitoring to track trends and alert on the degradation. G. Quick checklist for batch Wi-Fi complaint. Verify AP firmware and controller setting. Check wire uplink to AP errors, duplex and throughput. Confirm number of client per AP and consider streams. Run site survey head map for coverage holes. Use spectrum analyzer to detect non-Wi-Fi interference. Apply channel power and QoS change latest. Thank you. By Crook San Syakir Afiq dan Naim.